All right, let's do another example. So we're still working with our baby giraffe problem. The weights are normally distributed with a mean of 125 pounds and a standard deviation of 15 pounds. So now let's look at what this problem wants us to do. What is the weight of a randomly selected baby giraffe that has an area to the right of 0.394? So what is the weight of a randomly selected baby giraffe? This is important because of what's going to come later. An area to the right of 0.394. So let's get into our steps. So the first step is to draw the curve because we've been asked for the weight of the giraffe. Oops, not the probability. And I can do my center line. If only I could actually get it down the middle. All right. And that has a z-score of 0. And then the second step is to do our shading. So the amount that I'm going to shade is 0.394, which is 39.4% of the curve. So I'm going to shade roughly 40% of the graph, a little bit under. And then the direction that I'm shading, I want the area that I shade to be the area to the right this time. This one told me to the right. It could have also said greater than, more than, at least. Lots of different words that could have told me to the right. So since it's to the right, when I do this, I like to start my shading on the right. And I'm shading just under 40%. So I don't want to go to the middle. If I shaded to the middle, that would be 50%, but I only want to do 40%. So I'm not even going to get to the middle on this. So I'm going to start shading and I'm going to keep shading and I'm going to keep going maybe until about here. That looks like just under 40%-ish. So that's my unknown z-score. So it's the area to the right of the unknown z-score, and I didn't go past the middle because if I got to the middle, then that would have been 50%. So then step 3 is to use Excel to find the z-score. But Excel is fickle. And whenever we go to Excel, we have to plug in the area to the right. So this area, sorry, not right. When we plug in something to Excel, we have to plug in the area to the left. So this is 0.394. But that's the area to the right. When we go to Excel and we do norm dot s dot inverse, we need the area to the left. We need this area that I'm doing pink stripes over. So I need to figure out what is this area in pink. Take a minute to think about how you would find that area. Pause the video if you need to. All right, so we're going to find this area in pink by using the complement rule. I'm going to do 1 minus 0.394. And I can do it in Excel like how I have it written here, or I can find what it is and then plug in that number. So the area in pink is 0.606. That's this region here. The area to the left. That's what we have to plug into Excel. Always to the left. Excel gives us to the left, and we have to plug in to the left whenever we're working with probability. Excel likes less than. It doesn't want to give us more than. So now that I know that the area to the left is 0.606, I can go up into my Excel. I can turn my keyboard back on. I keep having to turn it off because it's messing up my pencil. Norm.s.inverse 0.606. And I hit enter. And there is our z-score. 0.269 is the z-score for this one. The first two were for the previous examples. So 0.269. That's our z-score. So remember, z-score tells you how far away from the mean we are. So we're like a quarter of a standard deviation away. And now step 4, we can solve for x. So using our x equation, x equals z times sigma plus mu. Our z-score is 0.269. Our standard deviation was 15, and our mu is 125. So we get 129.035 pounds. So the weight of a randomly selected baby giraffe that has an area to the right of 0.394 is 129.035 pounds. And the biggest difference between this problem and the previous problems that we've done so far is when you get to Excel, you have to do 1 minus the given area because Excel relies on the area to the left, and we were given the area to the right.